Hello and welcome once again to the Waters and Stanton video channel. My name is Peter Waters and my amateur radio call sign is Golf 3 Oscar Juliet Victor. I'm glad you could join me. You know, a lot of what I talk about on this channel is driven by you, the viewers. You ask questions. Some of the questions are quite complex. Some of the questions are fairly simple. But a question that I was asked very recently was, how much power can I feed to my antenna, and how do I know how much power my antenna will cope with? Well, it's a valid question actually. I can understand particularly newcomers asking that question, so let me tell you what I know and what I think. The modern ham radio station can run just a few watts or several hundred watts. There is license regulations, of course, limiting the power depending on your license. But there's a lot of difference between a few watts and several hundred watts. And as I said in the introduction, how much will your antenna take? Now, let me first of all explain, particularly to newcomers, that if an antenna is capable of handling a lot of power, it will equally handle low power. So if, for example, the antenna will handle 300 or 400 watts, then feeding it with just a few watts doesn't make any difference. It will still handle that low power. Obviously the signal strength at the far end is going to be a lot lower, but it does mean to say that the power limitation of the antenna only relates to the upper power. If you run lower power, then there's no problem. But of course, as soon as you run a lot of power, then things start to happen. And I can tell you from my own personal experience that I've seen all sorts of things happen, particularly in my early days of ham radio, when I didn't really fully appreciate the power and the damage that it can cause if your system is not properly installed, or if certain components are breaking down or can break down at certain power levels. With any antenna system, the most important thing is the weakest link, because the weakest link is the first thing that will break down and show the limitations. Now, ironically, the weakest link is not so much the antenna, although it can be. The weakest link is often before the power reaches the antenna. And one of the most obvious things is the connections, the connectors you make. Now, most radios on the HF bands use the PL259 SO239 connector, which a lot of people don't like, but you're stuck with it because that's what the industry has adopted. For VHF and UHF, we either go to BNC or to N connectors in the main. Now, if those connectors are not properly installed or sloppily installed, they may handle 10 or 15 or 20 watts, but they may not take too kindly to 100 watts, and they may well complain bitterly if you feed them with several hundred watts. You see, there's a world of difference between running 5 and 10 watts and running several hundred watts. Everything is much, much more demanding, and as I said just now, it's the weakest link that first shows the failings in your station. If you're running low power, even up to 100 watts, then you can use RG213, RG58 coax. That's fine, and you do need to make sure that the coax connectors are properly connected, and it's worthwhile spending some time on that because they will be one of the weakest links in the chain. Now, I'm not going to show you how to put on a PL259 plug. There's plenty of instructions on YouTube on how to do it, and if you've never put one on before, it's worth checking it out. And you do need a decent soldering iron. You need a soldering iron that's going to generate a reasonable amount of heat, because when you put a plug on to cable, that plug immediately starts conducting heat. So get yourself a decent soldering iron. But above all, check out on YouTube how to install a PL259 plug, or BNC, or N connector. If you get that right, then that's the first chain in the vents that you've dealt with, and hopefully it won't be a problem. Next in line is the coax cable. Coax cable is pretty tolerant really. RG58, which is the thinner cable, will handle 100 watts quite easily at HF. I wouldn't recommend it for VHF, not only because of the power limitation, the power handling limitation, but because it becomes rather lossy. If you want a general purpose cable, coax cable that will work from HF up to say 2 meters, then I would suggest RG213. And if you're going to go above 100 watts, I would certainly suggest you use RG213 as the minimum. Now, as soon as you use thicker cable, of course, it adds weight. And here we are, we're going down this path of, as you increase your power, so things have to be tougher, and tougher usually means bigger. So if you're going to run more than 100 watts, I would strongly suggest you use something like RG213 or some of the other coax cables. RG213 is basically okay for HF, but if you're going to go on to VHF and UHF, there are some specialised cables. They have a lower loss at VHF and UHF, particularly if you're going to run a long length of cable. So look at the cable specifications, look at the losses, and make sure that your cable is capable of handling the power that you intend to deliver to it. And also bear in mind, of course, that you may start off running a station with 40 or 50 watts, but in time you may get yourself an amplifier and you're going to run several hundred watts. Well, it's best to get it right in the first place, so it's best to invest in some decent cable, some decent connectors. Yes, decent connectors. There are some cheap connectors about, so get yourself some decent connectors and get the job right first time. A breakdown in cable or connectors can cause all sorts of problems. It can also cause some nasty RF burns if you happen to touch it, so get that right. If you see smoke coming from the connector or the cable, then just don't touch it, switch off, and you better start the job again. By the way, if you hear any noise in the background, my granddaughter, who's 4 years old, is here today, so apologies for any slight background noise. Now let's look at other components that will be in line. We accept that the transceiver and or the amplifier will be properly built, and so that won't present any problems at all. First thing to look at is your VSWR meter. Make sure your VSWR meter can handle the power that you intend to deliver at the frequency. It's no good just switching off an on-off switch on the SWR meter. If it's in line, that has to handle the sort of power that you're going to deliver. So check your VSWR meter, make sure it will handle the power. Now let's take the simple dipole. Simple dipole, in terms of the wire, the radiating wire, that's not really a problem. It doesn't really matter how thick or thin the wire is within reason. It'll handle the sort of power you're likely to deliver. But it's the bits in between. If you've got a dipole and you're going to insert a balun, make sure that balun will handle the power and again at the frequency. And if it won't, then you're going to destroy something, you're going to see some smoke. So check that balun out, and if you don't know whether it will or not, you better replace it with something which has been rated. Alternatively, one of the other ways is to make yourself a choke balun using the coax cable. You can actually use that, the coax feeder, as part of the balun. So if you check on YouTube choke baluns, you'll find an easy way of making a choke balun, and that will be rated at the same power handling as the coax cable. So that's one way I would deal with that. All antennas, or they should do, have a power rating, a manufacturer's power rating. And hopefully the manufacturer is going to allow a bit of leeway. If you are using trap antennas, the trap antennas should have a power rating, because a trap antenna will fail if you deliver too much power to it. Traps are susceptible to excessive power. So if you're using a trap antenna, check the power rating. And also bear in mind that the power rating of an antenna is likely to change depending on the mode. If you're using SSB, then you have peaks of power, but the average power is a lot lower. And generally speaking, you'll find that the SSB power rating is, say, a kilowatt, whereas the CW power rating may be 500 watts. That's because CW is a little bit more demanding than SSB, which has lots of peaks and troughs and gaps in between syllables and so forth. Now here's a warning. One of the popular modes today is FT8 data mode. FT8 sends a continuous signal for 10, 15, 20, whatever it is, seconds. But that's significant. That is much more demanding than SSB. So if you're going to run several hundred watts of FT8, and I do question whether you actually need to, but if you are going to run several hundred watts of FT8, then do bear in mind that you really want an SSB rating that is double the power that you're running on FT8. So if you're running 200 watts of FT8, you need an SSB power rating of at least 400 watts. So bear in mind, data modes, particularly FT8 and other modes that are continuous transmission, are very demanding. So if you've got an antenna that's rated at 400 watts SSB, don't think for one moment that you can safely run FT8 at 400 watts. You can't, or you may do for a short while, but eventually you'll damage your antenna. Of course, the same power rating warnings apply to antenna tuners. If you've got an antenna tuner which is external to your transceiver or your amplifier, again, make sure that that tuner will handle the power. So, in summary, the power rating of the antenna and the system, because it's not only the antenna, it's the feeder and the SWR meter, the tuners and the baluns and so forth, they've all got to be capable of handling the power. Believe me that you may well have a system that will quite happily tick along at 100 watts, but if you pump 400 watts into it and any of those components can't handle that power, you'll immediately get a problem. You'll see smoke, or you'll smell burning, or you'll get short circuits, etc., etc. So just be warned that as soon as you increase the power, the weakest link, which may not be evident at 100 watts, will certainly be evident at higher power. Running higher power requires an engineering assessment of your antenna system and the associated feeder and all the other bits and pieces. I don't want to put you off running high power, because we've all done it at some time. We all see the need for running high power. I say we all. A lot of us see the need for running higher power from time to time. This really is a warning to beginners. Just be careful. Make sure your station will handle that higher power. And if the antenna has not got a power rating, then be careful, because without a power rating, that antenna will at some point get damaged. But fortunately, most modern antennas, most reputable antennas, have a power rating, and fortunately the manufacturers generally are very generous. But don't rely on that. Take the power rating as the power rating. So there we are. This is in answer to a question which was very recently put to me, and I hope I've covered the topic in enough detail, and I hope I haven't frightened you in running high power. Goodness gracious me, no. I don't want to frighten you. I just don't want you to be the victim of high power damage, because it can cause all sorts of damage. And also, just don't touch the aerials when you're running high power, or even medium or low power. And the other warning I would say, of course, is that if you're running, particularly a VHF and UHF, a Yagi antenna, or well, almost certainly you'll be running a Yagi antenna. I say almost certainly, if you're running SSB, you'll probably be running a Yagi antenna. That antenna has gain. So if you're putting 100 watts into that Yagi, the actual ERP in the firing line of that antenna can be a kilowatt or more. So keep clear. There we are. Another video. I hope it's covered the topic that was raised by one of the viewers, and I'm sure it will interest others. In the meantime, enjoy your ham radio. Don't forget to press the subscribe button and enjoy your ham radio. It's a great hobby. Take care. Speak soon.